All right, so let's look at the Unit 2 question. A college's job placement office collected data about students' GPAs and the salaries they earned in their first jobs after graduation. The mean GPA was 2.9 with a standard deviation of 0.4. We're going to need both of those numbers. Starting salaries had a mean of 47,200 and a standard deviation of 8,500. We'll need those two numbers too. The correlation between the two variables was r equals 0.72. We're going to need that number. And the association appeared to be linear in the scatter plot. That's just additional comment to let us know that we can use this process without fear of a curve or some hidden stuff kind of messing with the data. So the first question says, write an equation of the model that can predict salary based on GPA. So the equation we need, okay, it's going to look like this. It's going to say some predicted output is going to equal some number plus another number being multiplied by what we determined to be the x value to be. Okay, so which one's which? What's our x? What's our y? So making a quick little sketch here of like an x and y coordinate. Okay, it says r is 0.72, so it's going to kind of follow this positive path like that, right? What's the x? What's the y? Well, even this question says write an equation of the model that can predict the salary, okay, based on GPA. So predict the salary, that means the salary is going to be the y value, right? You're always trying to predict your y value based on some x value, which will be, whoop, I put x, your GPA. Okay, based on a GPA, what can we predict will be our salary? So we've got to figure out this B0 and B1 number. To do that, let's take an inventory of what we have. Since GPA is going to be our x value, we can say our average x, our mean x, x bar, is going to be 2.9, and our standard deviation of our x will be 0.4. I'm going to put it over here. I'm going to say average y and standard deviation of y. The average y, the average salary was $47,200. And that standard deviation would be $8,500. Okay. Our r, I'm just going to put this r value here, and I might need this, okay, and I will need this later, and that's called r squared. R squared is literally that. We're going to take our r value and square it, okay, or multiply it by itself. And so we're going to take this and convert that to a percentage. That's kind of what the common thing to do is. So we'll take that 0.5184 and let's just round that to 52%. That's going to be good enough. So let's take a look at, this is kind of the big equation here, right? And when you do this, you have to get to solve for your B1 number first. And our B1 number is going to be R times the standard deviation of Y and divide that by the standard deviation of X. So when I do that, okay, I can say 0.72, okay, times the standard deviation of Y and divide that whole thing by the standard deviation of X. And what I get is 15,300. Okay, and now to find the B0, that is going to be the, they say take your average Y and take away this B1 number being multiplied by the average X. And so when I do that, okay, the average Y was 47,200, take away B1, 15,300, being multiplied by the average X. What you have to be careful of, okay, is order of operations. So does this calculator do the order of operations correctly? I believe it does, but we're going to double check this. We're going to say, we're going to do this part first, right? PEMDAS, order of operations, is do the multiplication first. Okay, and then I'm going to take 47,200, the average Y, and take away the last answer. And sure enough, it was right the first time. So please be mindful of the order of operations for that problem. So now that I have our B0 and B1 numbers, I can plug that into I can set that as my model. Okay, but I'm going to be a little bit descriptive here, and I'm going to say my predicted salary is going to be equal to B0 number, okay? The B0 number, which is 2830. The B1 is positive, so plus 15,300, and that's going to be multiplied by the X input. So what's the X input? GPA. So let's just multiply that by whatever the GPA they give us. So that would be an equation of the model that can predict salary based on GPA. Okay, it's important to know this equation and that equation. Okay, do B1 first, R times standard deviation of Y divided by standard deviation of X. Okay, B0 is your average Y, take away your B1 number we just found times the X average, okay, average X. Make sure you're paying attention to the order of operations. Okay, do you think this will be predictions will be reliable? Okay, explain. Well, that's where the R value comes in, okay? And the general strategy is to think of like an A or a B. That's going to be strong, okay? And then maybe like a low B minus maybe all the way to like a C. That's like the moderate, okay? And then maybe even to like a D maybe, but usually when we get to F, that's where it's weak / no or not reliable. Okay, it's not very reliable. That kind of goes back to this idea of the scatter. Okay, the more of a straight line it is, the stronger the more reliable it's going to be on this prediction. The more scattered it is, the less reliable. So 0.72 looks kind of like a C minus, right? It's going to be moderate. We're going to call that moderate reliability. Okay, so we're going to use these words here. We'll say, do you think this prediction will be reliable? They will be moderately reliable because the R is equal to 0.72. But we're also going to say how the variability of the salary is going to be explained by the GPA. Okay, so this is where the R squared comes in, and it's basically Mad Libs. Okay, it's basically the R squared. So we could say 52% of the variability of the salary or predicted salary is explained by the GPA. Okay, so what that basically says is if you can make a prediction of the salary, someone's salary based on their GPA, that's only half the story. It's only 52% of the story. There's other factors that can increase that. So the higher your R value is, the higher your R squared value will be, the more that explains any variability. So if this is like almost 1, which is like 100% almost, right, when you square it, that means basically it's all the explanation of your salary would be explained by your GPA. But in this case, we know there's other factors involved, so it makes sense that it's like 50% or whatever. Okay. All right, so that's kind of like that. It's just Mad Libs. Okay. This is like your Y value. This is like your X value. And that's your R squared. It's just Mad Libs. Okay. And that obviously is your R. And that's based on that idea. Your brother just graduated from that college with a GPA of 3.30. He tells you that based on this model, the residual for his pay is a negative 1880. What salary is he earning? Okay, so a residual is where you take the prediction, sorry, I lied, take the actual amount and take away the predicted amount. Okay, this is kind of like what you're doing here. Now, if we were given the residual and we're trying to find the actual, okay, if I add predicted to both sides, I could say the residual plus the predicted amount. Okay, that's kind of what's actually happening in this problem. We're trying to solve for the actual salary. So when we add this, just be mindful this is a negative. Okay, this is a negative number. And so that negative number will mean we're subtracting now. Okay, we're going to be taking it away because it's negative. All right, so first we have to figure out what the predicted amount is based on his GPA. So we could say 2,830 plus 15,300 times his GPA of 3.30. Once again, be mindful of order of operations. I feel confident this calculator does it on its own, so I don't got to worry about it anymore. Whoops, good. And then that's being multiplied by the GPA of 3.3. So we get a prediction, okay, that he will be making 53,320. However, he's got a residual of negative 1880, meaning to find out the actual amount, okay, we'll take the 53,320 and we're going to take away the 1880. And what we get here, okay, is 51,440, which makes sense because if we were predicting, okay, if we were predicting him to make 53,000, but his residual was less than that, then his actual amount was less than the prediction. Okay, that's the salary he would be earning. Okay, that is how you do the Unit 2 question.